Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So today we are going to discuss, actually last class also we started this solidification time, and last class we discussed what is the meaning of solidification time, what actually it means, and also we saw how to calculate the solidification time. Then we took one simple numerical just to emphasize the concept that we learned how to calculate the solidification time, and we solved that numerical to just see how the concept of solidification time is used in calculation of solidification time. Today we are continuing that lecture, and today we are going for some more complicated problems. If I am telling complicated problems, so what is the meaning of that? If you remember in last lecture, we just took the simple case. In that we just considered the solidification time of the casting. We didn't consider the solidification time, how much time it will take if riser is over there on the cast product or the mold. So today we'll take riser also, and we'll see if riser is placed on the casting, then what will be the solidification time and how we'll calculate that. Moreover, we'll also see if riser is there and some of the part of the riser is insulated and some condition is imposed over there, then how to calculate the solidification time. So to make this more clear, today we'll take two more numerical based on the solidification time where riser will be involved, and we'll try to uh, emphasize or we'll try to make the concept that we have learned more clear through those numericals. So we are starting with the numerical. These are the things that we have already. This is the problem that we discussed last time, but today we are taking this numerical. This is also a previous gate question. In every lecture, I am just taking previous gate question, a standard question, so that whenever a student, if someone is preparing for the gate also, it will be useful for those guys also. Okay, that is the reason. The example that in every lecture I am taking, it is from the previous year gate question. So here we will take this numerical, we will try to solve this. As I said that in this case, not only casting, the product that we are casting will not consider only the solidification time for that, will also include the solidification time of the riser. So first we will try to solve this numerical, and then after that we will go for the next part. In that we will take some more cases. Okay. So this numerical is the solidification time of a casting is proportional to volume upon surface area. This is V is for volume and A is for surface area of the part that we are casting, where V is the volume of the casting and A is the total surface area from which heat is dissipating. Two cubes of same materials. This is very important to understand. Two cubes of same material is same and size, so are cast using sand casting process. Top face of one of the cube is completely insulated. Top face of one of the cube is completely insulated. So in this problem, it has been given two castings are there. Both castings are of same material and their size is also same. But what is the condition? In one casting, one part, I mean one side is completely insulated. So cube is nothing but the combination of 6 square. So if one the edge is completely, or one part is completely insulated, that means the only 5 square will remain from where heat will be dissipated. So what we have to calculate? We have to calculate the ratio of solidification time for one insulated and the other one uninsulated. So we have to just calculate what will be the ratio of the time, solidification time for the one which is insulated, that is the first case if we are taking, and the second one which is the uninsulated. So if we through diagram we'll try to understand this one. So this is the first case we are taking, and this is the second case we are taking. So in first case we have a cube which one side or one part is insulated. Insulated means heat is not dissipating from that part, and another cube is there. This is, so nothing is insulated here. So all the 6 part you can see 1, 2, 3, 4. And this is the top and the back side. Similarly here, this is the one part, this is the another part, this is the another part, and this one is the another. So fourth, and this is the fifth one, and the back of this one is the sixth one. But here the condition is given that one part is insulated, means one section is completely insulated. That means from this part there will be no heat dissipation because this is insulated. So if this is insulated means only 5 square, as it is made up of 6 square, so 5 square is now free to dissipate the heat. So if we'll consider the surface area, I mean and the side length small a, so what will be the total area, as it is nothing but the combination of a 6 square. So a square area of 1 square will be a square if side length is a. So 5 part is now left with, because one part is insulated. So what will be the area, total surface area will be 5a square if we are taking this a1. Okay, and this cube which we are taking a2 as the surface area, it has the 6 parts and all 6 are square. If we are, and in the problem it is given both are having same material and same size, means if you are writing this a2, so this will be simply 6a square. Here it is 5a square because only 5 part is open through which heat will be dissipated, 6 part is insulated. Okay, so this is 5a square, this is 5. Last class, if you remember, we have already discussed solidification formula, solidification time calculation formula, and that was T is equal to a constant that we generally take gamma, and this constant, as I said in last class, is dependent upon the material which we are going to cast. So this is gamma, and this is volume upon surface area square of this one. Okay, so in this problem it has been clearly given that the size is same, means whatever the volume of this cube 1 is, the same volume is of Q2 also. So both are of same size and also material is same. So what is the difference? Because of the insulation of the first cube, here the surface area through which heat is dissipating, and here the surface area through which heat is dissipating. Because of that, their surface area is different. If you will see this formula, as this is a constant for a given material, so we can see this time is inversely proportional to the square of the surface area of 1 and the square of the surface area of the 2. This is from this formula we can say. So if we are writing time, solidification time for this one, if we are writing T1, and solidification time for this one if we are writing T2. So in the problem it has been asked what will be the value of T1 upon T2, that we have to calculate. That's what has been asked in the problem. So what will be the formula? From here we can see this time is reversely proportional to the square of the surface area. So what can we write? T1 upon T2. We can write T1 upon T2 is equal to A2 upon A1 and this whole square, and A1 upon A2 is nothing but this A2 means the surface area. We'll see the surface area of the second one. So total surface area is 6a square. A is the side length, and for 1 it is 5a square and whole square. So this a square and a square will be cancelled out. So this will be 6 upon 5 the whole square, and 6 upon 5 the whole square is nothing but 6 into 6 36 and 5 into 5 25. So this will be 36 upon 25. So this will be the answer. This will be the ratio of the solidification time of the first one to the solidification time of the second one. This condition in this problem if you want to draw, so suppose we are drawing here. So this is the pouring basin and this is the sprue, this is the runner, and suppose this is the mold area, this is the gate, and here is the cube. Okay, so this is the total. We are pouring here metal. In the last class also we discussed this one. We are pouring metal here, and through this gating system it is reaching here, and finally this is filling this area. Okay, this is the time. So in this problem riser is not given, but if riser can also be placed here, suppose riser is being placed here on the top of this one. Okay, so what riser will do, if metal is going, so riser through this one, metal will also go inside the riser. So if we are taking solidification time, so different solidification time will be there. The casting is there and then you have the riser. Okay, so in that case what will be the value, how we will calculate the value? In next problem we will take this. I hope this is clear to everyone that how to calculate the solidification time if a complicated problem, not a simple like that we discussed in the last class, has been given. So quite easily we can calculate this one. So to make things more clear, we will take the next numerical. So things will be more clear in that one. So this is the second numerical that we have taken, how to calculate actually the solidification time. The difference in this one is here actually casting is there and riser both are there. So in that case, how to calculate the solidification time? To just make these things clear, we have taken this numerical. Okay. So what is the question? A cylindrical riser. This is also a previous year gate question. As I told, I am just taking the standard numerical, especially the previous year gate question, so that if anyone is interested or anyone who is preparing for the gate exam, it will be useful for them also. That is the only reason. Okay. So a cylindrical riser of 6 mm diameter and 6 mm height. So in this problem, it is given that the riser is having cylindrical shape. So its diameter is 6 centimeter and its height is also 6 centimeter, is to be designed for a sand casting. So here height is 6 centimeter and diameter is also 6 centimeter, is to be designed for a sand casting mold for producing a steel rectangular casting of dimension. This one, this is the dimension 7 centimeter by 10 centimeter by 2 centimeter, having total solidification time of 1.36. For this casting, this is the solidification time which is given in the problem. Okay, so what we have to calculate? We have to calculate the solidification time of the riser. Okay, so we have to calculate what will be the solidification time of the riser. So if we will take this case 1 and case 2. So in the first case, we have actually a cuboid shape, this cuboid shape casting, which dimension is given. So suppose this is a cuboid shape and its dimension is given, and this is a cylindrical riser. Suppose this is a cylindrical riser, and here the diameter is given, means this diameter is given in the problem 6 centimeter, and height also, this cylinder height is also given, this also 6 centimeter. Here the solidification time, if we are writing T1, this is given in the problem 1.36 minute. This is given in the problem. So what we have to calculate, that we have to calculate here what will be the solidification time for this riser. So as I draw the last numerical, as we discussed, same metal, suppose this is the molten metal which is going inside through this gating system and reaching in the mold cavity, and this same metal is reaching in the riser also. So in this problem, what is the catch point? The catch point, or the main important point that you have to understand is, whatever the metal you are pouring, the same metal is going in the casting, that will be cast over there, and that same metal is going in the riser also. That you have to understand. So if same metal is there in the casting, in your mold cavity, and that same metal is going inside the riser, what does it mean? The constant in the solidification time that we have written in the formula, that will remain same for both. That is the main point in this numerical. Okay, so if we'll take the ratio of the solidification time of the casting, and if we'll take the solidification time of this riser, so that gamma or that constant will be cancelled out, because it will be same for both the materials, for the casting as well as for the riser, because the same material is being solidified over there in the casting as well as in the riser. That is the reason gamma will be cancelled out. So this you will have to think, and if you are able to think in that way, then this numerical is very easy. After that, nothing is there. So how we will solve this numerical? So we already know solidification time, the formula is gamma volume upon surface area. So what will be the volume of this cuboid? All the dimensions are given. So we know what will be the volume. We can write volume of this cuboid, V is equal to 7 into 10 into 2 centimeter cube. So simple. What will be the surface area of this one? A is equal to twice. We can write 7 into 10 plus 10 into 2 plus this 2 into 10. So the surface area is also known. What will be the volume of this cylinder? It will be simply pi upon 4, a square of the diameter. This is, and then this height, this pi by 4 d square h. Here the height and this diameter both are same. So if we are writing d is equal to h, so we can write this one pi upon 4 and this d cube, because h and d both are same. What will be the surface area? The surface area will be this curved part through which the heat will be dissipated, and these two circular sections at the bottom and at the top. So what will be the total surface area? Pi dh plus twice pi upon 4 d square. D is the diameter. So this is the surface area for this cylinder, means a cylindrical riser, and this is the volume and surface area for the this casting. So what we have to calculate? We have to calculate how much time this cylindrical shape riser will take for the solidification. So if you are writing the formula, so we know T is equal to gamma volume upon surface area square. So this time is directly proportional to its volume upon surface area square. So what we can write, the material is same in the casting as well as in the riser. So we can write here, if we are writing T2 means solidification time for the riser upon solidification time of the casting. This we can write is equal to gamma, it will be cancelled out. So we can write T2 means V2 upon V1 into this A1 upon E2, this whole square. So what is V2? It is the volume of the second one. Second one, we have assumed this cylindrical shaped riser. So volume of this riser pi by 4 d cube, because d and h both are same. What will be the volume of the first one? Volume of the first one will be, and here the value is given. We can just put the value because this value is given. Here it is 6 centimeter and 6 centimeter. So it will be pi by 4 6 cube. So this will be the volume of the second one. What will be the volume of the second one? First one, volume of the second one will be first one will be simply 7 into 10 to 2. So that will be, all the dimensions are in centimeter. So there is no problem. That's why we are not changing. Into what will be the surface area? It is, as it is inversely proportional. So it will be A1 upon A2. So what will be the surface area of the A1? We just now calculated twice 7 into 10 plus 10 into 2 plus this 2 into 10. And what will be the surface area of this one? Area of this curved part plus area of these two circular sections at the top and the bottom. So here also all the values are given. So this will be simply pi d square plus twice pi by 4 and d square. So we just have to put the value. Once we will put the value, all the value in this one, this will finally comes out if we'll take. So this time T2 which this riser is taking for the solidification, it will comes out 3 minutes. I'm not doing all the calculations. I'm not putting all the value. If we'll put all the value, finally it will comes out 3 minutes. So what we have to do? We just have to remember this formula and we just have to thoroughly read the numerical, what has been given and what we have to calculate. So maximum these two types of numericals are generally being asked in the exam. And what those two types of numericals are? One numerical will be directly based on the formula where riser will not be involved. Also, no part of the casting that we are going to produce will be insulated. Insulated means the heat dissipation will be from all the part of the casting that we are going to produce. If these kind of conditions are not there, so this comes under the simple numerical. Simple numerical means no condition is imposed over there. In second case, what will be the case? A riser may also be involved in the numerical as well as the conditions will be imposed on the casting. Some of the part will be insulated, some of the part will not be insulated. So all these things we have to consider. If we know how to do these things, if we are able to draw the diagram and we are able to visualize the things, then it will become very easy to solve the numerical. So with this, we'll stop this lecture here, and next class we'll come up with some other numerical based on this, some tough numerical, or we'll jump on the next topic from the casting. So for the now, this is what we are stopping here. So thank you so much for watching the video. Thank you.